I got into mechatronics my freshman year. I didn't even schedule to be in this class. It was actually an accident, but in the first week, I was with my friend and we fell in love with this class.
Before we get to model rocketry, I wanted them to know, how does this work? So we started off exploring Newton's laws, how it's in place in rockets, but we started off with basic straw rocket, where it's an engine like you blowing the air, you're giving energy, and then you see that it moves further.
We are building a homemade car out of this tray, so we can learn about forces and how they affect objects, which is part of Newton's third law.
Which explains how everything has an equal opposite reaction. So when a force is going down on a surface, it launches the rocket up, so it has an equal amount of power to lift it off the ground.
We also looked at the centripetal forces caused by the axles in the body, and we mitigated that a bit with the use of a straw.
In my advanced mechatronic process, they build everything what they learned, they put in practice.
So we designed the fins and the custom nose cones. We can do a lot of research on how its shape can affect drag and how it can cut through the air faster.
We have the original fins right here, and we just measured out to get like the area. And then we have a new design that we drew out and we're cutting out right now that we're gonna try onto the body tube.
I'm trying to make a new cone with a different shape that will hopefully get us to a higher max height. I'm going to change sort of the angle that it curves at, and I'm probably going to change the height a little bit to help it sort of cut through the air a little bit better as it's going up. What we're trying to improve with most changes to the rocket is to get a higher max height or apogee.
Right now, I'm working on taking the data that we collected during our last 3 rocket launches, the temperature outside, our maximum height or apogee, the humidity during our launches, and I'm putting them into a spreadsheet.
I'm putting it into a 3D modeling program, so I'm getting the measurements and I'm making it into an actual three-dimensional object, plug it into a 3D printer, and then we'll leave it to print overnight.
We have all the equipment we need in this room to build anything we want and pretty much customize it as much as we need. Kind of just gives us no limitations.
They learned those SolidWorks skills and then how to use laser cutter, 3D printer, UV printing. So all this machinery we know how to use, but how do we, with a purpose, use them? So when we go to the launch, first thing first, safety is always at our top priority. So we have a safety check crew, which always checks when one person does, other person come and check, make sure they have done proper connections.
3, 2, 1.
My goal is for them to be curious about the world, and we are here to provide the environment and then encourage them, and they need to crave for learning, crave for what's out there. This is just a baby step, and hopefully they find their passion in the field. It's a huge field, and you never know, someone could be working at NASA.
I personally love the idea of working for SpaceX or anything associated with SpaceX, and I would love to be a SolidWorks engineer, SolidWorks designer, and through that I can go through PCC and take many of their courses through mechatronics and SolidWorks design.
I am confident that my students will go out and make a difference and contribute to society in their own way.